The slope of the line is usually defined as the rise over the run. Rise over run. So if I was to write that as an equation, rise over run. But of course, the word rise doesn't really translate. If I have a couple of points, it doesn't really make a whole lot of sense, nor does the word run. So usually what we end up doing is, when we're talking about the rise and the run, we have 2 points. Let's call this x1, y1. I'll call this point x2, y2. So 2 points, they both have an x and a y coordinate. The second point has a subscript 2, and the first point has a subscript 1 of each of those. So what I'm going to do to figure out the rise, this is my rise, compared to the run. If I want to figure out the rise, I'm looking at the change in my y coordinate. And to figure out the change in a y coordinate, I'm going to do y2 minus y1. I'm going to figure out where I end up minus where I started. That's just how you figure out the change in something. You do final position minus initial. That should be minus y1. All right, and then for the denominator here, for the run, we're going to do the same thing, but with the x coordinates. It's going to be x2 minus x1. Now, actually, it doesn't matter which one of these points I called my first point and which one I called the second point. If this, in this situation, it looked like I went up and to the right. So, since I went up, my rise was positive. And since I went to the right, my run was positive. So overall, this is going to be a positive number. Let's think about what would happen if I switched those around. If I said this is my first point and that's my second point, well, I would have a rise that's negative and a run that's negative. You would end up with a negative divided by negative, which, if you recall, is still a positive number. The only thing that was different about these was the sign. So the fact that still ends up as the same sign, you can kind of see the number overall is going to end up being the same. You might do this, so this is with a positive slope line. You might do this, think about how it would work with a negative slope line as well. All right, so let's do an actual example. Find the slope of the line that contains 2, 3, and negative 4, 5. Well, I'll go ahead and call this my first point and this one my second point. So my first point here, my second point here. I tend to just take these in whatever order they're given in the problem because I don't want to forget which one is the first and which one's the second halfway through a question. So what I'm going to do, this is x1, y1, x2, y2. I'll do y2 minus y1, that's 5 minus 3. That's the numerator of my fraction, because I'm trying to find the slope. I'm computing rise over run. And then x2 minus x1. This is negative 4 minus 2. So I get 5 minus 3, which is 2. Negative 4 minus 2, which is negative 6. It looks like, well, I'm taking a positive divided by a negative number, which overall is negative. And I can cancel, I can reduce my fraction down to 1/3. So I have a slope of negative 1/3. And just to verify that it didn't matter that this was the first and that's the second point, because this actually is a negative slope here. Let's try it the other way around. Let's see what happens if I did 3 minus 5. So this one minus that one over this one minus that one. 2 minus negative 4. This would give me a negative 2 up top, and 2 plus 4, which is 6 down below. We still get a negative 1/3 as our slope. You can see it still works out. What can be said about the slope of any horizontal line? Well, let's think about an example. If we have a horizontal line, we have some x1, y1, and we have some x2, y2. But if this line is horizontal, then what I can say about this is that my y coordinates must be the same. So instead of calling them y1 and y2, let's just call them both y. So when I go to figure out the slope, which is y minus y over x2 minus x1, which is 0 over, well, something. I don't know exactly what number that would be, but as long as I'm not choosing the same point, it's going to be something other than 0. 0 divided by something gives me 0. So that means if we have a horizontal line, necessarily the slope must be 0. Let's think about what happens if we have a vertical line. x1, y1, x2, y2. If this is vertical, it means this point is directly over that point, which means they have the same x-coordinate. So instead of calling these x1 and x2, I'll call them both x, and let's see what happens here. y2 minus y1 over x minus x. So this is something, I don't know what it is, it can be really pretty much anything, over 0. Well, it can be anything except 0, because again, we want to choose two unique points. We don't want them to have both the same x-coordinate and the same y-coordinate. They have the same x-coordinate, so they have to necessarily have a different y-coordinate. So we get something other than 0 divided by 0. This is undefined. Can't divide by 0. So when we're talking about a vertical line, necessarily the slope is undefined.